Okay, today we're going to talk about the last few types of sampling methods that we need to learn about. And I'm in the book again, mainly to show you sort of how to navigate this. So we're in chapter 4, and we are in the sampling and surveys section. I believe we're down here to other sampling methods. But where I want to be today is going to be roughly 217 all the way to like 221. So we're sort of in the right spot. Okay, so I think this is page 215, so I'll just kind of go down. And you probably realize that this is several pages combined most of the time. So we talked about stratified yesterday. So today we're going to talk about cluster samples. And they're very often confused with stratified sampling, so I want to be able to distinguish the difference between the two. And the main thing is clusters are supposed to represent the population. So they are supposed to be heterogeneous in that they're different within but similar between. So if you remember from yesterday, stratified random sampling is when you stratify to create groups that are similar within but then different between. Well, clusters are the exact opposite. Every cluster should be different within and representative of the population as closely as possible, and then that means they'll be similar between. So one cluster is pretty much going to look like the next cluster, and that's, if you can accomplish that with clustering, then you could create a very good sample and have a representative sample for your population. So I'm going to give you some notes on that in just a second. This is a really neat little example, but I have one in the notes as well. So you can read through this if you would like. So, and as always, you can always come back and check your understanding to make sure you really understand everything. Okay, so I'm not sure why that just did that. Okay, so we're to page 220. Now, we're kind of shifting gears here. You need to understand what inference is. So we've talked about it a little bit, but inference is when you get information from the sample, and it's usually some sort of statistic, say a mean or a proportion, and you take that sample statistic and you infer back to the population, or you infer information about the population. Inference is extremely important in this course. It's about 40% of what will be covered on the AP exam, so it's extremely important. We don't actually start formal inference until second semester. We will talk about inference all throughout the first semester, just sort of laying the foundation for that. So inference is really important. Now, you may be wondering, because we talked yesterday about all the different types of samples, or all the many, many, many samples that you can create from one population. So how do we take one sample and get one sample statistic and feel confident about what we're inferring about the population? Well, we're going to start with the concept of margin of error. So margin of error tells us how close the estimate tends to be to the unknown parameter in repeated random sampling. So you're actually thinking about, if I repeatedly sample over and over and over, what would those sample statistics look like? Like, how spread out would they be? What would their shape be? So we're going to be learning about that. Margin of error is something you probably already are somewhat familiar with, so I'm going to give you some notes in just a second for that. So what can go wrong when we create a sample? Well, undercoverage can happen in several different ways. And one of the ways that it can happen is if your sampling frame, we talked about that yesterday, the list from which a sample is actually chosen doesn't actually match your population, you could have undercoverage. Undercoverage occurs when some members of the population are left out of the sampling frame. This is a type of sampling error. So we're going to be learning about sampling errors and something called non-sampling errors that give us bias, but for a different reason. So undercoverage is when your sampling frame does not match your population. It can also occur for other reasons. We'll talk about that in just a minute. The next type is non-response. Non-response occurs when an individual chosen from the sample can't be contacted or refuses to participate. This is known as a non-sampling error. This is not an issue with creating the sample. It's something that happens after the sample has already been formed and you can't actually get information from individuals in your sample. So how bad is non-response? You may want to read through that. And response bias is also a non-sampling error. It's a systematic pattern of incorrect responses. Response bias is typically when people don't feel comfortable answering the question. It can be for various reasons. Often people feel guilty responding that they have a certain behavior in their life, that kind of thing. It could also be that the interviewer is not one that they feel comfortable responding to. So maybe it was a female interviewer and they were asking about questions about a male about their views about feminism, that kind of thing. They wouldn't feel comfortable telling a female how they truly felt. So that is response bias. And then question wording is also very important. So you can have something called a leading question, which basically makes the responders feel, dumb or stupid or bad for answering in a certain way. All right, so let's go to the notes. We're going to take a few notes. All right. Okay, so what is a cluster sample? Why do we use a cluster sample, and how is it different from a stratified sample? So we already talked about it a little bit, but let's go ahead and summarize this. A cluster sample is a sample created by dividing the population into smaller groups. A sample created by dividing the population into, let's just say, similar groups. Ideally, these groups or clusters would mirror the characteristics of the population. Would mirror the characteristics, and I'm going to abbreviate for space here as well, the population. Then choose, randomly I will add, then choose an SRS of clusters, depending on how many people or observations you need in your sample. And then all individuals in each selected cluster are used in the sample. So strata and clusters are often confused. So strata are similar within. I don't need the within part there, but different between. So like I said, they're exactly opposite. Clusters are different within. You don't want all the same type of person or individual. You want the cluster to look very similar to the population. And it's actually sort of hard to accomplish that, but it can be done if you design your sample correctly. But they will be similar between. So one cluster should pretty much look like the next cluster. Okay, so here's an example that we're going to go through just to basically stress what's an SRS, what's a stratified sample versus what's a cluster sample. So a school librarian wants to know the average number of pages in all the books in the library. So the library has 20,000 books arranged by type in shelves that hold about 50 books. So explain how to select a simple random sample of 500 books. So you would label the books, and we talked about this yesterday. It would depend whether you're using a table. If you're using the table, you have to have 5 digits because you have 20,000 books in your population. And use a random number generator or a table, okay, of course, to select 500 5-digit numbers between 00001 and 20,000, ignoring the repeats. Okay, that's going to be a really hard task, very hard, and it would be very time consuming. So let's talk about another approach that we could use, which would be stratifying. So how would you stratify? Remember, strata are supposed to be similar within, different between. So explain your choice of strata and one reason why this method might be chosen. So divide the books into strata based on type of book, such as fiction, biography, etc., because we suspect each type of book has similar number of pages. Okay, so assign labels to the books in each strata, so you'd have to figure out how many were in each type of book and use a random number generator or table to actually create an SRS from each type of book, and you would combine the randomly selected books of each type to create the stratified random sample. Okay, the third way, explain how to select a cluster sample of 500 books. Explain your choice of cluster and one reason why this method might be chosen. So since each shelf holds about 50 books, make each shelf a cluster. Now, we're assuming that the books on each shelf are going to be what? Representative of the population. So represent the population fairly well. That might be an issue, so we'll talk about that in a minute. So you assign labels, and because there should be about 400 shelves, and all I do is take 20,000 and divide by 50, it should be 001 to 400. Okay, and randomly select 10 shelves, and every book on the selected shelf will be used in the sample. All right, so what are the strengths, what are the weaknesses with each of these methods? Okay, so the SRS would be hard to accomplish. Just be hard to carry out. It'd be a really good way to do it, but is it the best way? So stratified actually might also be hard or be difficult to accomplish, but is probably the best approach. And the reason is because if you stratify, you feel like you think certain types of books have different page lengths. And whenever that's the case, stratifying may be your best option for how to sample. So clustering is going to be what I would think is the easiest, but certain shelves tend to hold the same types of books. This is probably the worst or the weakest method, but the easiest method, okay? So it just depends how important this information is to you, and if you really need to be precise, then it would be worth the time and energy to invest in doing the stratified sampling. And always remember the activity we did yesterday. That really drives home the whole point or the whole need to sometimes stratify, just to make sure that you get some individuals or observations from each of the different strata, because you feel like whatever characteristic that it is that you're measuring is different for those strata, and that is always going to be an important thing to do. All right, so let's move on. And I think I may have to pick up with another really short video for this page, so I'm going to cut right here and then we'll pick up right back here.